In my last video, I did derivation of equation of motion. So in this video, I want to be applying the derived equation in solving some problems involving involving a motion. So I'll first let me first quickly recap the equation of motion. The first one we have there was v equals to, we have v equals to u plus at. Then we have second one as s equals to ut plus half at square. So we have the third one as v square equals to u square plus 2as. Then we have the fourth one as s equals to u plus v all over 2 outside t. These are the equation where v is the final velocity, u is initial velocity, a acceleration, t time, and s is distance. So having done this, let's start solving the equation we have here. The question we have here. The first one is, we said a body which uniformly retarded comes to rest in 10 seconds after traveling a distance of 20 meter. Calculate its initial velocity. So which formula is suitable in solving this? If we test all the formula, the most suitable formula there that you can use is the one that has s equals to u plus v all over 2 then outside t. This formula. Why does it this formula? Because this formula contains no acceleration. Because we don't have acceleration in the question, what we have is if you write our parameters out, what we have in the parameter, number one, time is what we have. Time is 10 seconds. What other things we have? We have distance, which is 20 meter. So we are looking for u. Our final velocity, since the body is retarding, the final velocity is 0. So before the body can retard, on getting to the maximum, v becomes 0. So these are the things we have, and then that's why this formula is suitable in solving the problem. Every other formula you can't use them because they contain acceleration, and there's no acceleration here. So using this formula, we can say that s, which is 20, say 20 is equals to bracket u, our u is unknown, plus v, which is 0 all over 2, then outside t, which is 10. So from here we can our 2 can divide our 10. Let's quickly clean this place so that we can use the board properly. So okay, fine, we are done. So our 2 can cancel 10. That will give us 5. Then from here we can see that we have 20 equals to 5 multiplied by u, that is 5u. Then by dividing both sides by 5, our u is equals to 4 meter per second square. I mean per second, 4 meter per second. So that is our initial velocity. Okay, so let's move on to the next one. The next slide, I have another question there. The question goes by said a car moving with a speed of 60 kilometer per hour. So let's write out our parameter. Initial velocity. A car moving with a speed, so that's our initial velocity. So u is equals to 60 kilometer per hour. That is going to be 60 kilometer per hour. 60 kilometer per hour can be converted. You have to convert it to meter per second. So it's going to be u equals to 60 multiplied by kilometer means 1000 divided by per hour. You have to convert hour to seconds. Maybe 60, that's conversion from minutes, maybe from hour to minute, then multiply by 60 again, so minute to second. So if you do this thing very well, your answer should be our answer should be 50 over 3 from the calculator here. So we have u equals to 50 over 3 meter per second. Okay, let's move on. Then uniformly at a rate of 5 meter per second square, so we have our acceleration. Our a is 5 meter per second square, so that one does not need any conversion. So when brakes are applied, calculate the time taken to reach the velocity. The final velocity, that is v, is 36 kilometer per hour. So that one too, we have to convert it to meter per second. That will be 36 multiplied by 1000 being kilometer divided by hour from hour to minute, from minute to second. So if you cancel here, our answer is going to be 10 meter per second. Okay, so this one now, we are calculating. So we have the initial velocity as 50 over 3. We have final as 10, and we have the acceleration as 5. So we are looking for the time taken to reach the place. So let's move to this place and then let's solve here. So from here now, from what we have gotten, we know that our v is 10 meter per second, our u is 50 over 3 meter per second, our t is our acceleration is 5 meter per second square. So like we are looking for t, to reach the maximum, to reach that place. So t is unknown, so we are going to say t equals to unknown. So if t equals to unknown, so what are the things, which formula are we going to use in solving this problem? We have initial velocity, we have final velocity, and we have the acceleration. This acceleration is going to be negative because it's retarding. So put negative sign there. So the formula we can use, we have v equals to u plus at. So v is 10 equals to u, which is 50 over 3 minus 5t. So by multiplying through by 3 here, we have 30 equals to 50 minus 15t. Because when you want to multiply 3 times 10, that will be 30. 50 over 3 times 3, that will give you 50. Then minus 5 times 3, that will give you minus 15. So collect like 10, we can have 30 minus 50 equals to negative 15t. So by doing this, your answer is going to be negative 20 equals to negative 15t. So if you divide again by negative 15, your t is going to be 20 over 15. As negative becomes negative, then t is going to be 4 over 3 or t equals to 1 point that should be 1.333 seconds. So that is the solution to that. Okay, so let's move on to the next one, the next question, which is this. You can pause this and try the question. Pause it and try whether you can solve this. A car accelerates uniformly at a rate of 10 meters per second square from our initial velocity. So the first thing you have to do is your acceleration A is 10 meters per second square. So you have to first write that one down. Initial velocity, so your u equals to 36, like the way we used to know, since we know that it is given in kilometer per hour, so you have to convert it to meter per second. So it's going to be 36 multiplied by, since it is kilometer means 1000 divided by 60, then multiply by 60 again. So u is going to give you just like what we did the other time. That's going to be 10 meter per second. That's our u. Then I haven't gotten the u. Our time is 30 seconds, so t equals to 30 seconds. T equals to 30 seconds. What other thing? Find the distance. We're looking for s. S is unknown. So which formula are we using? We can use, since we have UAT, so we can use S equals to UT plus half AT square. So that's going to be S equals to UT so S equals to UT. That our U is 10. Then we 10 multiplied by time. The time is 30. Time is 30 multiplied by half multiplied by acceleration, which is 10, multiplied by time again, which is 30 square. So by doing this, let me clean this side. So by doing this, it's very easy now. So we can just use our calculator to get our answer from here. And use our calculator just to finish it off. That is going to be 10 times. It's going to be 10 times 30. Okay, but before then, we can use our 2 cancel 10 here. It will be 5. So we are going to be having s equals to 300 plus 30 squared, that is 900. 9,000 divided by, that is that should be 4,500. So finally your s should be 4,800 meter. So that is the answer to that, 4,800 meters. So you can convert this down to kilometer by having s equals, by dividing by 1,000, so 4.8 kilometer. So this is the solution to the question. Now another question, and this one is that a car, I beg your pardon, a car moves from rest with a uniform acceleration of 2 meters per second square. So let's write the acceleration, write the parameters. A equals to 2 meters per second square for the first 10 seconds. That means t equals to 10 seconds. So we don't know the velocity then, so we can calculate the velocity. V equals to u plus at. Since body is starting from rest, u is 0. So we are going to be having 80, that is 2 times 10. And your answer is going to be 20 meters. So the first one is 20 meters. Since the body starts from rest, u is 0, so we don't need to write u again. V equals to u plus 80, u is 0, so a is 2, then t is 10. Okay, so it then accelerates at a uniform rate of 1 meter per second square for another 15 seconds. So let's say, so it means that this one is, we have 2 velocity, so this one is v1, so the v2, that is when the body accelerates again. So in this one now we're having u plus 80. Our initial, we're going to be, not, I might not write u, I may write it as v1, because my v1 is now the initial velocity. So I may write it as v1, which is my initial velocity. So can be v1 plus 80. So v2 equals to v1. v1 is 20 plus 80. Okay, a is now 1 multiplied by t for how many seconds? For 15 seconds. So times 15, so t2 is 15. So v2 is equals to 20 plus 15, and that will give us 35. So we have v1 as 20, we have v2 as 35. Okay, so it's continuing at a constant speed. Okay. So now they ask you to draw the velocity time graph for this motion. Okay, let's draw the velocity time graph. In drawing this, it's kind of tricky. The question is kind of tricky, so we have to draw our vertical axis, then our horizontal, then okay, let me change my, so when the body starts, this is velocity, and then this is time, velocity against time. So this body moves, started from rest like this, and accelerates until it attains a velocity of, the first velocity we calculated was so that was is it 10 or 20? Let me check. That was 20. while the second one is 35. So first one was 20, the second one was 35. So you are going to put it like this. Okay, this is 20. Then it accelerates again. So continue like this. Doing this one too. So this second velocity go to 35. Before it was now moving with constant speed. Constant speed. Let me draw it very well. Constant speed. Then finally come to rest. Okay. Now the first movement, when it moved first, it was how many seconds did it travel? The first one, I changed. So the time for traveling here and the time for traveling here. So the time it's used to travel in the first one, so you can write this place as 0, that is origin, we're starting. So the time it's used to travel for the first one, that was, it used 10 seconds. 10 seconds, so this is going to be 10. So the total time for the second one is 25, because that is 15 seconds, make it 25. So it retardates. This is the time it was decelerating. So the time it was decelerating, it decelerated after. So the time it used to accelerate on the uniform speed, the uniform speed is 70. So 70 plus 25, that will give us 95. That will give us 95. So that is the time it stops accelerating. I mean, it stops moving with constant speed. Then later decelerates. When it decelerates after average seconds. That's after 10 seconds. So this is going to be 115. So the time frame here is 10. So this is how the graph will be. The body moves until it attains 20 speed of 20 meters per second. Then it accelerated again 1 meter per second. So that is it, to attain 35 meters per second square per second. Then later maintain the speed for 70 seconds before finally come to rest. So this is how the graph will be. So then, let's say from our graph, the total distance traveled, that is S. So to calculate this, we are going to use area under the. We are going to reduce this shape, the area of this shape, to calculate the time it traveled. So the first one here is A. Let's call this place A. Call this place B, C, and D. So the first one we have triangle. Second one we have trapezium. C is rectangle. Then D is triangle. So I'm going to use the area of each of them to calculate the area inside each of the shape. Then we add everything together. So for A, we are going to be having so let me clean this. We don't need this one yet. So A, the area under A is going to be area of a triangle, and that is going to be A equals to half base times height, and the base is 10, so it's going to be half times 10 times height. The height is 20, that is times 20. So our answer here is 100 meter square. Then the second one, B, the area under the trapezium, the formula for finding area of trapezium is half bracket a plus b outside h, where a and b are the two parallel sides. So the parallel sides here is this side and then this side, while the height is this side. Okay, so it's going to be half bracket our a, that should be 20, plus our b, that should be 35. Then our height is going to be 25 minus 10. The distance between 25 and 10, and that is 15. So that is going to be 15 here. So if you finish this is going to give us 20, that's 55, so that should be 412.5, 412.5 meter. So that is the distance covered. Now distance covered by C. So I'm going to be cleaning this shape now, so that you can have something to solve on. So the distance covered by C, I've calculated this place, so I think this one can go, since I've calculated it. So okay, now the distance covered by C, the shape of C is rectangle, and that the area of rectangle is length times breadth. So it's going to be 70 multiplied by the breadth. What's that? That should be 35. We are calling that. So that is the maximum velocity we got. So 70 times 35, that should give us 2,450 meter. Then the last one, which is D, that is half base times height, is another triangle. Half base times height, and that is half multiplied by base. The base here is 10. Then the height remain 35. That is the maximum speed at 10. So this is half base times height. Okay, so, half base times height, that is okay, base, half base times height, that is base is 10, then height, that is 35. So this is going to be 5 times 35. So D is going to be 5 multiplied by 35, because 2 here, that is 5. So 5 times 35, our answer should be 350. Base times height. Okay, that should be, beg your pardon, this is supposed to be 20. This is supposed to be 20. Okay, Okay, this is supposed to be 20. The last one is supposed to be 20. This is supposed to be 20. So let's see. Supposed to be 20. So we have here as 20. So we are having 20 multiplied by 20 multiplied by 35. So we have 20 multiplied by 35 by 35. So our answer is going to be 350. So the total distance covered is now going to be 350. It's not going to be solution, addition of everything starting from, okay, you can say starting from 100 plus 412.5 plus, let me clean all this, so 412.5, then plus 2450, 2450, plus 350, all equals to um 3000 3,000 300 and that should be 3,312. That should be 3 points. I'll convert it to this thing. I'll convert it to, so that is 3.3125 kilometer. So that is the answer to that. So what they asked to find again is and they asked us to find so that's in this you calculate the average speed of the whole journey. To calculate the average speed is total. Average speed means total distance covered divided by total time taken. So let me change the color here. Okay, total distance covered. The total distance covered is okay. Total distance covered here is 3,000. That is 3.31 kilometer, 125 kilometer. So average speed equals to distance covered over time. So the distance covered is that distance covered by this is 3,000 3,125. That should be 3,312.5 divided by time. What's the total time? Total time taken there is by the time that's 115. So speed equals to this. When you divide your answer should give you 28.8 meter per second. 28.8 meter per second. So they say we should calculate the retardation. Retardation, that is time is coming down. Retardation is at what point did it retard? Okay, I've cleaned it. So it retard at when the speed was 35. So that's 35. The time it used to retard, according to the question, was 20. So the retardation is going to be 7 over 4. 7 over 4 will be 1.75. 1.75. Oh, okay, let's just leave it as 1 over 4 meter per seconds. So now, having gotten this, the last question there is the maximum speed attained, and from the question, the maximum speed attained by the body attained the maximum speed at v equals to 35 meter per second from the graph we draw. So these are the solution to it. You can leave you can go through it again, pause it, and then see the way we have solved. Thank you. God bless you.